Domination University.
Hello, everybody. I am Sami A Saurus, and this is the first punk rock space talk. This is presented by Domination University. And our goal today is to talk about space and some science. So there's a lot of information out there, and I know it's kind of hard to keep up with all of it and to understand all of it. There's a lot of huge words, a lot of kind of scary things when it comes to learning about space and science. So I'm just going to take this opportunity to kind of just do it in a nutshell. So we'll kind of give you some bite-sized chunks so maybe you can understand how space works a little bit more. So I am not a scientist, although I wish I was, but I am a space enthusiast. I am self educated as far as this goes. I've always been so interested in learning about the nature of the universe. So, this is kind of a culmination of information that I have learned. So, I will do my best to explain it to you and make some sense out of it. So, I'd like to welcome you to my kitchen, first off. As you can see, we have a lot of spacey sci fi things here in my kitchen. Not only do I very much enjoy space, but I seem to kind of surround myself with it, hence my sweater and such. I definitely don't see it as a trendy thing, although lately it has become aesthetically trendy. And I think it's good in a way. It's kind of a bummer because it takes some of the specialness away from those of us that have really dedicated our lives to try to understand space and science even more. But at the same time, I think it's bringing awareness to the masses. So you can go into Hot Topic or whatever, and you can pick up a cool space hoodie. And even though some people might not truly understand the origins of that or where it comes from, it's still raising awareness for the universe, and maybe it'll help inspire people to learn a little bit more. So here we are, about to learn some stuff. So where does one begin when we are talking about space? I think it only makes sense to start at the very beginning. So it's, of course, one of life's big questions of how this all began. And scientists have done our best to try to figure out how that started. And obviously, my cat has some input on this right now. Jedi has some really big stuff he wants to add, but we're gonna get to him later. But either way, so at the very beginning, there was what was called a singularity, which is a single point where it is theorized that all of the matter that exists in the entire universe was condensed to a tiny, small point. Now, where that came from, nobody knows. We do not understand yet. It is very possible that if the multiverse theory is in fact correct, that maybe it was a previous universe that collapsed upon itself, condensed down, and then therefore exploded once again to create what we have here. Unfortunately, nobody does know, but we can't be expected to know everything yet. We are learning little by little. We are trying to understand these things, and we've made a lot of progress so far. So, everything that we are talking about, for the most part, is going to be theorized how it began. But as we progress through how things work, we have been able to understand the mechanics of how the universe works, or at least how we think that it works at this point. So, back to the singularity. There's one moment where this singularity collapsed upon itself and exploded, which is what we call the Big Bang, which is what we believe is the origin of our universe. As that happened, it basically exploded everything, all the mass, out into the universe. Now, at this point, there were no stars, there were no galaxies, there was nothing except for essentially space dust that was floating around in the cosmos. It took quite some time for those particles to coalesce to each other to be able to create what we know of as solid matter at this point. So it was about 200,000 years after the Big Bang when the first stars started to blink into existence. There was one and two, and then billions, basically gravity caused all of these particles to connect together. We believe it's gravity. I mean, gravity, there's a lot that we don't understand about gravity. It might have been some kind of electromagnetic force that caused these things to attract to each other. But we do believe that it was some form of gravity that caused these particles to attract to each other. And eventually, as they attract to each other, they were able to basically squished down to a point where they were able to create nuclear fusion, which is how stars create light. So nuclear fusion began, and that was the first light in the universe. So there's about 200,000 years of complete darkness while the universe was trying to figure itself out. So now we've got some stars. There's many different kinds of stars. We're not completely sure what the very first one or the first few were, but eventually there was enough stars that they started to gravitate towards each other. So their gravity and their mass kind of coalesced all of these things together to form galaxies eventually. And the first galaxies they anticipate were probably about 1 billion years after the Big Bang. So for about 800,000 years, there was rogue wandering stars just hanging out in the middle of the void. And eventually they ended up forming galaxies. It is believed that the first galaxies that formed were spiral galaxies, just like our Milky Way galaxy. There's a second type of galaxy as well that is prominent in the universe, and those are elliptical galaxies. And they're kind of like a football shape. It's like a football or an egg. And they believe that for the most part that those were created by the merging of spiral galaxies. So you've got two spiral galaxies coming at each other, and everything just kind of caused it to end up being kind of an egg shape. So the expansion of the universe has been going exponentially since the very beginning of time, which, if you were wondering when that was, it's about 13.774 billion years ago is when they believe that the Big Bang happened. And we're able to use that we're able to see that or understand that by using the telescopes that we just in this 20th century have been able to create so that we could truly see as far back as possible. It's really unbelievable how far we've come with science, from Galileo with the little tube staring into the sky, seeing the Galilean moons of Jupiter and thinking that, this was it. And thankfully, we've had so many wonderful scientists to be able to understand that we are not the center of the universe. We are one of billions and billions of galaxies, and our planets are one of trillions of galaxies. So far in this century, since we've had electricity and since we have had the technologies that we have been able to design these incredible machines that give us an eye into the universe. So this is all very new to us right now. And I think that's very important to keep in mind, is that we have not figured it out all yet, but we have come leaps and bounds since we have began to try to understand how this all works. It will take time for us to understand more, but we have to take everything as it comes. We can't expect to, be born as a baby and be running marathons after day two. It takes time. So we have been very blessed with a bunch of really amazing astrophysicists and a bunch of philosophers basically that have been able to come up with these ideas and think, hey, what about this? And then we have these amazing scientists that are able to try to figure out how can we prove this. So I just like to give a shout out to some of the big names that have helped us to get where we are today. So that being said, what we do understand is that as far back as we can see is about 13.7 billion years. And we understand that nuclear fusion is what causes the stars to shine. And we understand that these galaxies were created as a result of these stars being attracted to each other, basically. So now we're expanding through space. So it's 13.7 billion years ago. Our solar system was created, or at least I would say our sun was created many years after that. It feels like an eternity, but really, if you think about it, our Earth is only 4.5 billion years old. It sounds like forever. But if you think about that in conjunction with the entire age of the universe, we're kind of at the beginning of it, to be honest with you. If you think about it, we have not had that many cycles so far since the beginning of our universe. So, who knows what the future will bring? But our star and all of the matter that we have, that we know of, that's here on this planet, that's in our solar system, all of that is a result of supernova explosions. Why, you ask? I will tell you. So, I am definitely not a chemist or a physicist, but my understanding of this is, so we all know that the first element on the periodic table is hydrogen. That is the beginning of everything. And when hydrogen atoms fuse with each other, they create all of these other elements. So everything is kind of based on hydrogen some way or another, at least as far as we know. So, in order for these atoms to fuse together, you need great force. You need a lot of heat and you need a lot of pressure. So what happens is the atoms are in the middle of these stars and they're smashing into each other. They're smashing into each other at great speeds. And the output of energy from these atoms smashing into each other is what actually causes this energy and causes what we see as photons as light. So as we progress, the stars eventually all have a life cycle. All stars are different. They all have different kinds of ways that they go out. Supernova explosions are not as common as I think we would imagine that they are. But basically, what a supernova is, it's when basically the star collapses in upon itself. So it's using up all of this energy. It's using up all of this energy over all of this great amount of time. And eventually, it just can't support it anymore. So it squishes it on itself and makes this massive, massive explosion. Now, in this explosion is when a different kind of fusion occurs. There are elements bashing into each other because of this massive explosion that could not exist in any other ways. So, example, the iron in our blood that was forged in supernova explosions. We don't know if that was there from the very beginning of time, from the initial Big Bang. It appears as if that is a possibility, but we do know that we are made of stardust, essentially. If it was not for these explosions, we could not exist in the way that we do now. Life seems to always find a way. So who knows what kind of evolution there would have been if we didn't have these circumstances. But given the fact we do have these circumstances, the blood that's pulsing through all of us that keeps us all alive, that's all a result of supernova explosions. So I feel like we are pretty lucky to be here. And we're lucky to be able to understand this because it's an absolutely beautiful thing to know that we are connected to the stars. The gold, if you have any gold on your hands, I am a silver lady, so I do not have gold, but also silver and gold, and a lot of these precious metals were also created by these supernova explosions. And it sends out all this stuff into the universe. And then eventually, just like from the Big Bang, all of these little particles start to coalesce together and then eventually squish down and eventually causes enough pressure that boom, nuclear fusion. And that's how we have the life that we have on this planet today. I mean, our sun is our life force, and it is considered a average star. It is a medium yellow star. Its life cycle is probably 8 to 10 billion years old. We don't really know for sure. But eventually, most likely, our star will not supernova. It does not appear that our type of sun is in the position that it will supernova. But instead, what it will do is as it starts to use up all of this fuel that it has, eventually it's going to start running out of fuel. Everything's going to start kind of hitting each other a little bit slower, and it's going to put less output of energy. And eventually, our sun will start to swell, and it is going to get cooler, and it is going to balloon out to where all of the four inner planets will end up being engulfed by the sun, most likely. This is definitely what the general consensus is. So, really, no matter what we do on this earth, in the end, it doesn't matter because billions of years from now, we will be consumed by our sun. So, right now, we are in the habitable zone, which is also called the Goldilocks zone. So there's a very specific area away from the sun that life as we know it can exist. It cannot be too hot and it cannot be too cold. It has to be within a reasonable temperature for humans and all of the wonderful creatures we have on this earth to exist. So it's a very small line. For example, Mars, which we believe is, the second most potentially habitable place, it gets really cold when the sun's not shining on it. It is cold out there. It gets extremely hot when the sun is shining on it as well. It has a thinner atmosphere than we have. So we might be able to work with that with the technology that we have to be able to create climate controlled environments for humans to be able to live on that rocky planet. But that remains to be seen. We definitely have some goals. I know they are talking about sending people to Mars and seeing about sending the first people out there and having them kind of check it out. And I think it's a great idea. I think it's going to be incredible for us to explore another planet. I'm a little bit worried. I will be honest with you that we haven't treated our planet very nicely, so it makes me a little bit nervous that if we do go to Mars, I hope that they treat the planet respectfully. So that is the only other planet that we have any option of being able to habitate on whatsoever. Mercury is a tiny little rocky planet. It is very close to the sun in the big picture of things. It is extremely too hot. There's no way we could ever habitate that area. Venus, want to talk about greenhouse effect. I'm sure you guys have heard about the greenhouse effect. Its atmosphere is so thick on Venus that the UV rays that come in from the sun can't escape. So the rays are just bouncing basically from the surface of the planet to the atmosphere and is getting trapped. So it causes this planet to heat up. It is just like a hellish landscape that is thick with storms and heat beyond anything that we can probably even imagine. So Venus is out of the question. Then we've got Earth, right in the Goldilocks zone. Here we are. Thankfully, we have a nice access, so we're able to have seasons. It moves around. Yes, it does get cold. Yes, it does get hot, but it is still manageable for life to be able to exist. Then we've got Mars, as we talked about. After Mars, there's a big gap. There is the asteroid belt that basically is in the middle of this gap between the inner planets and the outer planets. We are not 100% sure about the asteroid belt yet at this point, but it is theorized that there was planets back in the day or rocky asteroids, what have you, that have collided that basically broke it into pieces, and then it just ended up becoming this asteroid belt, which is basically chunks of rocks that just orbit the sun forever. All right, so we understand about the inner planets. Now we understand about the asteroid belt. Now we're getting to the next phase, which is the gas giants. So the next planets, it's very interesting. They are unlike anything that we can even imagine here. There's no core, there's no rocky ground. to stand on. It's basically just giant balls of gas. So honestly, it's almost a star, but it does not have enough pressure to create nuclear fusion. So therefore, it ended up being just a big gas planet. So we've got, so let's see, we went past the asteroid belt. So we got Mercury, Venus, Earth, Mars, asteroid belt. Now we've got Jupiter, which is absolutely huge compared to our planet. It is absolutely massive. I'm not sure the exact number of how many Earths that you can fit inside Jupiter, but it's a lot. It's interesting because it has the most beautiful aesthetics when we look at photos of Jupiter. There are these incredible bands of these thick cloud formations. And one of the coolest things about it is a lot of them are going in opposite directions. So it's really neat. We don't quite understand exactly how that all works, but we've been observing it for 300 or 400 years at this point, which brings me to the Great Red Spot. There's a giant storm that exists on Jupiter, and it has been there for hundreds of years. When it was first observed, Jupiter was first observed, you could see this Great Red Spot, and it's kind of like a gigantic hurricane that you could fit many Earths inside of this massive storm, and it's just raging on for eternity. We don't know how long. It could stop tomorrow. It could go forever. We have no idea, but it's pretty cool. It's very iconic part of Jupiter. Whenever you draw Jupiter, you're always going to see that Great Red Spot. It also has auroras because of its magnetic field, which is pretty cool that we can actually observe that. Saturn also has auroras as well. It's kind of neat to be able to see from here, from an outside perspective, seeing the glowing auroras from the solar wind that is hitting the magnetic field of these planets. It's awesome. So Saturn, also a giant planet, big gas giant, but what makes that more unique to us and super iconic is Saturn's rings. So Saturn's rings are actually pretty thin compared to the size of the planet. They're only about, 20, 30 feet thick at any given point. And what makes the rings? How can we see these rings? Well, it's chunks of ice, it's chunks of dirt, it's chunks of rock. It's a bunch of these leftover parts of the universe, comet dust, whatever. There's all these little things that have kind of been floating around in space that ends up getting stuck in the gravitational pull of this gas giant and has created these rings around it. And one of the really cool things is Saturn has a lot of moons. There's I can't remember the exact number, but it's in the realm of between 40 and 60 moons. But my favorite moon is Enceladus. Enceladus is a frozen ice planet, basically. But what makes it so cool is it's geothermal. So the core of this moon is actually warm. So even though the space on the outside is so cold that it freezes the outside layer of Enceladus, which is basically it's a ocean planet, underneath the water, or I'm sorry, underneath the ice is water because of the warm core that is melting the ice from within. So it's very interesting. We don't know if there is any kind of sea life down there, but I did hear that they're going to be sending some kind of expedition out there to try to get some samples. Now, rather than drilling into the ice of Enceladus, the way we're going to get the samples, which ties into how Saturn's rings are also created, is there are some areas where there's cracks in the ice, and there is basically ice and water particles flying out into space from these jets of Enceladus. So what they're doing is it's kind of shooting out and Saturn's picking them up, and then they end up causing these other rings of Saturn, and it's absolutely amazing to be able to see them be created. It's so cool. So the way that we're going to do some samples of Enceladus is they're going to fly a spacecraft through some of these plumes and gather samples of the water ice and see what's in there. So I'm very excited about that. I think that's pretty cool. There's definitely a possibility that there's some kind of life under there. Who knows? Also, Titan, which is a moon of Jupiter, they think that it's very possible that there is potentially some kind of small life that does exist there. It's interesting because Titan looks very similar almost. If you would see a photo, there's mountains and there's lakes and stuff, so it almost looks like there may as well be life there. But the lakes are, they're liquid methane. It's not water. So we do not know if there is water on Titan at this point. It is so cold out there that most likely not, but who knows? So that is another option in our solar system where we theorize that there might end up being life to be found. So after that, we've got Uranus and Neptune, which are also gas giants. I mean, these are huge planets, but still pale in comparison to the size of the sun, and pale in comparison to the size of our galaxy, and then even more to the size of the universe. But we thought for the longest time that our heliosphere, which is basically the edge of where the sun has any effect on space, we thought that it was a little bit smaller, honestly, than it actually is. So let me backtrack for a second. We have just left the gas giants, but outside of the gas giants, there's what's called the Oort cloud. And the Oort cloud is just, it's basically a lot of smaller floating objects that surround our solar system that are still somehow locked in by the gravitational pull of the sun. And it's where a lot of the small protoplanets are at. Which brings me to Pluto. Let's talk about Pluto for a second. I need to drag a cigarette before we talk about Pluto. Big debate on Pluto. We got a big Pluto debate. We all learned, those of us who are old enough, we learned that there were 9 planets. Pluto being one of them. Tiny little rocky planet all the way at the end, pretty much covered in ice. Doesn't look very fancy, but nonetheless, we recognize that there is a small other planet orbiting the solar system. It was found, I believe it was in the 30s, by Lowell in Flagstaff, Arizona, where I used to live, actually. So it's pretty cool. I used to live right near the place of Pluto's birth, essentially. So we all learned that there was 9 planets, Pluto being one of them. There's no debate on that for a long time. And then all of a sudden we have the technology to be able to see further. Now we're noticing that there are a lot more small rocky bodies out there between Pluto's orbit and the Oort cloud. So now what do we do? Now do we have to have thousands of planets? Are we going to teach kids thousands of planets? I do not think so. So the reason why they essentially downgraded Pluto was to make it more manageable to understand what these planets are. So they basically said, all right, what we know of as our, inner and outer gas planets, those are our main planets. But now we have so much more understanding of these other worlds that we didn't even know were out there. So they basically called them, it's not a protoplanet, they are just smaller versions of a planet. Now, what's the difference between a planet and an asteroid? How do we know that Pluto's not just some giant asteroid? Well, basically what is considered to be a planet is a spherical object that clears the orbit to some degree around it. So if there are any kind of little rocks floating through space or whatever, it has to have enough mass and gravitational pull that it will actually kind of suck those things into its orbit. So that's why it was considered a planet. So it still is a planet. I actually had a friend of mine who is not very scientifically savvy ask me where Pluto went. Pluto's not a planet anymore. Where did Pluto go? Did it blow up? I could not make this up. Literally asked me where Pluto went. It did not go anywhere. It is still there. We have just changed its categorization to honor all of the other worlds that we have found that are of similar size and stature. So you've got the Oort cloud surrounding with all of these other Pluto-like bodies, chunks of rock, all of this stuff surrounding us. Definitely not out of the heliosphere at this point. So you keep going. You think we're out of the heliosphere? We're not. It recently, over the past couple years, we have found out that it is so much larger than we thought. We sent out the Voyager 1 and 2 spacecrafts in the 70s, and we just sent them on a mission, on a one-way trip out there to go see everything that we could see along the way. We actually used the slingshot method to cause it to go even faster. We would basically have it get kind of sucked into the orbit of some of these planets and slingshot it out, which helped it to gain speed. And it was going and going, and we thought for sure at a certain point we were going to be out of the heliosphere, out of the realm of the solar wind. And it kept going, and it went for a couple years longer than we even thought that it would. And finally, it was a big party, I'm sure, at NASA where we were actually finally left the heliosphere. So I think that's a huge triumph for us that we have made a craft in the 70s, also in the 70s. I mean, that was a long time ago. Our technology was not as great as it is. And we were able to make a craft that was able to communicate with us this entire time and to go explore the solar system. And now it's just flying out into space indefinitely. Will anybody find it? It's more than a needle in a haystack, for sure. But just in case, the scientists of the time in the 70s decided to put some messages on the Voyager spacecrafts. They actually made what's called the golden record, and they made a record out of gold, which would help it from breaking down. We wanted something to be able to not break down. So obviously, plastic or wood or something like that eventually would deteriorate. But gold is very strong, so we used a very hardcore metal, and we made this album. We put some music that we have made here on Earth. They put photos of people. They put sounds, different sounds on Earth. So just in case somebody finds this, they have a little bit of an idea of what Earth is like. They also put what they considered to be a map, which there's some debate on whether this was a good idea or a bad idea. They essentially made this map of where Earth's location is. And how do you do that? How is that even possible? Well, there was 7 pulsars that we could see, which pulsars basically it's a spinning object, and it shoots out this light, and we could actually see these flashes. So we thought it was something that's a little more prominent than just using static objects in the sky. So they pretty much said, here's Earth and here's all of these pulsars. So you'll be able to triangulate our configuration by knowing where these pulsars are. Now we have found a lot more pulsars, so it makes it a little bit more confusing because it's not as simple as we thought it was. But nonetheless, we tried. We definitely tried. They put some different kind of messages on the Voyager, just hoping that if somebody found it at some point, they might be able to appreciate that and be able to find where we are, which could be good, could not be good. It vastly depends on what kind of creatures that potentially would be finding this. We don't know. We have no idea. So basically, we're just biding our time and wondering if there's going to be any visitations as a result of the Voyager spacecraft that we have sent out. All right, so to conclude Punk Rock Space Talk, we have just started at the very beginning of the creation of the universe, and we have worked our way all the way through the solar system at this point. So I hope that gave you a little bit of a more clear understanding on how this came to be. And, we only understand as much as we can, but we are definitely doing our best. And we are open to new information that is coming. We have a lot of time on our hands to learn as we go. So, definitely looking forward to staying open minded and accepting any new information that comes along. But I hope that you enjoyed this punk rock space talk. I just want to give a shout out to Domination University for presenting this video. And like I said before, shout out to all the big scientists that have helped us come to where we are right now. Galileo, Kepler, Stephen Hawking, and even Carl Sagan and Neil deGrasse Tyson, which are, 20th century heroes, I think, to help bring science to the masses and help people to be able to understand these concepts a little more easily. So there we go. This is Punk Rock Space Talk. Thank you guys so much. Before we go, one last thing. My shirt that I'm wearing right now is the Planetary Society shirt. I am a monthly contributor to the Planetary Society. And what that is, it is funded by and started by Bill Nye, the science guy, and Neil deGrasse Tyson. They're the two main people that run this organization. And what it is it's a crowd-funded organization that helps to further space exploration without government funding. So this is not NASA. This is scientists that actually want to understand these things more. So it takes people like me and you to contribute what we can and help fund for these scientists to be able to learn more on their own terms. So if you are interested, please contribute to the Planetary Society. And it's a little thing that you can do to help make a difference and help us learn about the universe. So until next time, Punk Rock Space Talk. Enjoy.